Hey, my name's John Broadwell, and I'm the creator of the Serial Wombat open source project, which is an I2C to everything firmware that's loaded on some microcontrollers. You don't write code for our Serial Wombat chip, you control it over I2C using Arduino or MicroPython or C# libraries. So today we're going to be talking about the first of 4 boards in the new Phase 2 Serial Wombat 8B Kickstarter, and this is the PCB0042 LSD low-side driver board. So the link to the Kickstarter campaign is down below. I hope that you'll pop on over there and follow the project and then support us as we go through this first phase. And don't hesitate to give me feedback on the hardware. I will make changes based on your suggestion if we're early in development. So why is this Phase 2? Well, because we had a Serial Wombat 8B Kickstarter last year, which I guess we call Phase 1 now, where we introduced 8 innovative boards, all based around the Serial Wombat chip and its firmware, that are designed for different interfacing tasks. Well, there were some problem domains that we didn't necessarily hit with those, and so now there's 4 more boards coming out, and LSD is one of those 4. It's a 8-channel I2C controlled low-side driver board based on N-channel FETs. It can drive up to 4 amps per channel, up to 8 amps across the entire board. You can pick one of 16 different I2C addresses, so you could have as many as 128 different drivers out there just with the default firmware. Also in the future, we'll support a specific relay mode that's designed for closing relays and then reducing the amount of power that it sends via PWM to reduce the overall load, which can be really great if you're driving a lot of relays. So this board is good for pretty much any DC application up to 24 volts. It has flyback diodes on each channel, which is important on an inductive load. When you shut it off, it can generate a voltage because as the magnetic field collapses, and this diode will dissipate that to help keep your board from being noisy or upsetting the rest of your circuitry. This board does not have current limiting, so you'll have to make sure that you don't put a short circuit across the FET. It could destroy them if you do. If you need current limiting, take a look at the new PCB0046 high-side driver board or one of our H-bridge driver boards. This board comes fully populated with screw terminals and header terminals for everything you need. Let's take a look at the hardware now in more detail. At the core of all Serial Wombat 8B boards is the Serial Wombat 8B chip. It is a CH32V003 microcontroller loaded with the Serial Wombat firmware. And you send this chip commands over I2C. You can see up here we've got ground, power, clock, and data. There's 2 copies of that. 2 quick connectors that allow you to hook up the same way, and I threw some extra I2C connectors on each end in case you want to daisy chain multiple of these boards together. You can configure it with one of 16 different addresses using these solder jumpers. It starts at address 0x60, and you can pick anything from between 0x60 and 0x6F. You can also recompile its firmware to use entirely different I2C addresses. There's 2 onboard I2C pull-up resistors if you need them for your bus. Your bus should only have 1 set of pull-up resistors. On each end of the board, there are header connectors and screw-down connectors for power input, and that can be up to 24 volts and up to 8 amps for the entire board. There are 8 power connectors in the front, again, both header connectors and screw-down terminals for heavier applications. Of course, anytime you're talking about power engineering, you're also talking about heat dissipation. And so there are a variety of aspects that impact these FETs that we use here. In the future, there'll be another video that looks in depth in an academic way at the actual current limits under different circumstances, because really it's all about heat more than it is about power. If you're driving inductive loads, it's important to have a flyback diode. When you run current through a coil, it generates a magnetic field. If you stop running current, that field collapses and it tries to continuously drive current for a short period after you shut it off. You need a diode in your circuit in order to act as a flyback to recirculate that power until it dissipates as that magnetic field collapses. The Serial Wombat LSD board has a flyback diode for each set of inputs. Each input has an optional green power LED that will indicate if it's turned on or off. Those are enabled by closing this solder jumper for active LEDs. There's also an LED for VN, which indicates that you have power on these, and an LED for VDD, which indicates that you have logic power. Another option that you have is to give up one of the channels and repurpose it into a voltage input measurement. It'll take the voltage that comes in, divide it by 11, and feed it back to the analog to digital converter that's available in the Serial Wombat chip. This is really useful if you want to know whether or not your board has power or not, and to verify that the power that you have is maintaining the voltage that you expect. This board uses the same form factor in terms of holes and screw-down terminal connectors and communication connectors as the Serial Wombat HSD, which is a board we'll be looking at in the future. Let's take a quick look at the performance of the Serial Wombat 8B in a real-life application. Here we can see we have the Serial Wombat 8B board, which is attached to two power resistors I have on channels 1 and 6. And we are hooked up to a high power supply, providing 20 volts and an adequate amount of current availability. So let's fire this thing up and take a look and see what happens. I'm going to use the Wombat panel. I'm going to use the Wombat panel to enable channels 2 and 6. And what we can see is that we're pulling just south of 8 amps. We're seeing the board is starting to heat up, and we're seeing a rise, temperature rise, 137, 140. The room here is about 60 degrees Fahrenheit. Still heating up a little bit as we drive more and more power through these resistors. You can see that we have a green LED on. I've enabled those LEDs for each of the channels. The resistors are definitely getting hot, going up over 200 degrees. And we're still sitting at a pretty stable, about 140 degrees. So we're seeing a temperature rise of about 80 degrees Fahrenheit, about 40 degrees Celsius. And that's pretty typical what you're going to see when you're running around 4 amps per channel. This is at 3.3 volts. It's a little more efficient at 5. And this is without PWM. If you PWM, you spend some time in the transition regions and you'll see that temperature go up. So just a quick example of using the Serial Wombat chip to drive two loads at what I would consider to be moderately to high power for a lot of hobby applications. I hope you see the value in the Serial Wombat LSD board that I've created. Leave comments down below with any last-minute improvements you'd like me to make. I often implement user feedback when I create my boards. For instance, the version that you see in the videos didn't have quick connectors, but since I developed this board, I've been convinced by my users that, boy, every board ought to have quick connectors. So that is a user request that has been implemented. So until I talk to you again, hop over to the Kickstarter, follow it, pledge later, and until we speak again, have fun and keep making stuff.